Okay, now let's do the 13th. Now the derivative of d by dx of this whole function. Okay, ax plus b whole power n multiplied by cx plus d whole power m. Okay, now assuming this to be two functions, product of two functions. Okay, this is u and this is v. If you assume it, then you can write it as u dot v whole dash, which is equal to u dash v plus u v dash. Okay, derivative of u multiplied by v plus u multiplied by derivative of v. Okay, so this is the formula. Now let's write u is equal to, this is u, ax plus b whole power n. So u dash will be derivative of ax plus b whole power n. Okay, so now if you see, this is in the form x raised to n. Okay, x raised to n. Assuming, if you assume this to be x, then x raised to n. Since this is not x, we are assuming it to be x, so we'll use the chain rule here. Okay, that is multiplying by its derivative. Okay, multiplying by the derivative of the function which we are assuming as x. So this can be written as this. Okay, this will be written as n into ax plus b whole n minus 1. We are assuming this to be x. Okay, now again chain rule, d by dx of ax plus b. Okay, which is equal to n into ax plus b n minus 1. Derivative of ax will be a d by dx of x plus d by dx of b, which is equal to n ax plus b n minus 1. Derivative of x is 1, so a into 1 is a, and derivative of b is 0 because b is a constant. So a into a, this will be n a ax plus b whole n raised to n minus 1. So this is u dash. Okay, now let's calculate v dash. So v is equal to cx plus d whole raised to m. Okay, which implies v dash is equal to d by dx of derivative of cx plus d whole raised to m. Now this is also is in the form x raised to m. Okay, or x raised to n. So since we are assuming this to be x, we'll use a chain rule, that is multiply by the derivative of this function. Okay, so we can write this as m into cx plus d whole raised to m minus 1, derivative of this thing again, cx plus d. Okay, which is equal to m cx plus d whole raised to m minus 1 d by dx of cx plus d by dx of d. This is equal to m cx plus to d, cx plus d whole raised to m minus 1. Now c d by dx of x plus the derivative of the d, the constant will be 0. So this, the derivative of x will be 1, so c into 1 will be c. So we can write this as mc cx plus d raised to m minus 1. Okay, this is v dash. Now we got u dash and v dash. Let's put these values in the formula. So we have u dash is na ax plus b whole n minus 1 multiplied by v. So v is cx plus d whole raised to m. So next plus, okay, plus u is ax plus b whole raised to n. Next v dash is mc cx plus d cx plus d whole raised to m minus 1. Okay, that's it. Now this is almost over. We'll just simplify this. Okay, now you see we'll take some expressions common. Now we'll take this ax plus b raised to n minus 1 and cx plus d m raised to 1 common. Okay, so taking ax plus b whole raised to n minus 1 and cx plus d whole m minus 1 common. Okay, these both are common, so we have to multiply and we have to get this. Okay, this is plus, so this multiplied by something must give you this. So ax plus b n raised to n minus 1 multiplied by na will give you this. Okay, this multiplied by na will give you this thing, and this multiplied by cx plus d whole raised to 1. Okay, cx plus d will give you this thing. How do you get this? See, you know there is a formula a raised to m multiplied by a raised to n, where the bases are same, a. Okay, then the powers will be added, a raised to m plus n. Okay, you know this, a raised to m into a raised to n is equal to a raised to m plus n. Because both the bases are same, the powers can be added. In the same way, cx plus d and this are both same. Okay, its powers can be added. So cx plus d m minus 1. So okay, this is csd plus, assuming this is a and this a raised to m and a raised to n, a raised to m plus n. This is m and this is power is 1 is n. Okay, plus 1, m minus 1 plus 1. So this minus 1 and negative 1 and positive 1 cancels, you get cx plus d whole power m, which is here. Okay, so when you multiply this both, you get this. Okay, the same way, plus now this multiplied by mc will give you this. This multiplied by mc will give you this, and this multiplied by something must be this, that is ax plus b. Okay, because ax plus b whole power n minus 1 multiplied by this ax plus b whole power 1 will be ax plus b whole n minus 1 plus 1. Okay, so this will be ax plus b whole power n, because 1 and 1 will get cancelled, minus negative 1 and positive 1, so you get ax plus b, this thing. Okay, that's it. You can assume its power to be 1. It's actually 1. Its power is 1. Okay, so that's it. This is the answer.